Hello everyone. The topic of our presentation is discovering electric vehicles market diffusion by simulating consumers' purchasing intent. So our research question is discovering the electric vehicles market diffusion through simulating the interaction and the influence between different consumers based on each consumer's support for the electric vehicle. Our hypothesis is that social influence will have an impact on consumers' purchase intention of electric vehicles. The purpose of our research is to investigating the impact of consumer interactions in social networks on market diffusion of electric vehicles. So our presentation will include the following contents. First, we will describe the design of our model. Then we will introduce how to implement the model through code. Next, we will demonstrate how the model works, and then we will discuss our evaluation and analysis of the model. Finally, we will talk about how to improve the model in the future work.
After the group discussions, we conceive a model. The agents are vehicle consumers, each with two attributes, purchasing intent and social influence. During the model initialization, we create consumers based on the number inputted by the user with a random position. The initial purchasing intent is set using a normal distribution based on the initial mean purchasing intent controlled also by the user, while their influence is randomly assigned from 1 to 10. Each consumer then connects to the nearest different numbers of other agents based on their influence. These connections are unidirectional and are used to transmit purchasing intent. The connections have random weights reflecting varying degrees of acceptance of the opinions. This also reflects real-world social dynamics. And in order to prevent extreme values from already influencing others, the weight is kept to ensure that each influencer transmits no more than 1/10 of their own intent per cycle. Each consumer divides their purchasing intent by their influence and multiplies it by the connection weight to transmit to other consumers. Then consumers update their intent by simply adding the average of the intents received. Updates to purchasing intent are also kept between -100 and 100 to maintain the stability. The consumer's color will be updated based on their purchasing intent. Red indicates low purchasing intent on EVs, green indicates medium, and green indicates high intent. And then we are going to explain our NetLogo code. Overall, our programming implementation aligns closely with the initial modeling approach. For example, each consumer agent has attributes of purchasing intent and influence. But during the coding process, we treated the connections of the consumer, which is a link, in the model as agents with independent attributes, although the initial model concept did not consider that. Additionally, we assigned two extra attributes to the consumer agents, which is influenced consumers and received intent. In the setup procedure, we initialize the environment by cleaning any existing data and create consumers based on user input. Each consumer is randomly placed within the environment, and then calling the initialize intent procedure to initialize the purchasing intent for each consumer based on a normal distribution centered around the mean defined by user input through this slider, and with a standard deviation of 50. The intent is then clipped to stay within the -100 to 100 range. And then we assign a random influence level to each consumer, and the range is 1 to 5% of number of the consumers with a maximum of 10. And finally, it calls the established networks procedure. In this procedure, each consumer identifies the nearest other consumers up to the number of their influence and create links from the consumer to these neighbors. Each link is assigned a weight that does not exist 1/10 of the consumer's intent, ensuring that no consumer excessively influences another. And in the to-go procedure, we firstly set up a stop simulation checker to check if a predefined simulation endpoint has been reached. User can set up the expected simulation time of the model through the slider. Then each consumer divide their purchasing intent by their influence and multiplies it by the weight of each link to calculate the intent transmitted to each neighbor. And then each consumer update their intent based on the average intent received from their links. And the updated intent is again kept between -100 and 100. And finally, call the update colors procedure to check the update consumer intent, which changes the color of the consumer to visually indicate their level of intent. And we have also some utility functions to debug and test encoding only.
Now let's take a look at this demo. First up, our model is locally simple. It included the number of agents and iterations. This order represents the society overall perception of electric vehicles. A value of 100 indicate for support for electric cars, while manual 100 means complete support of fuel-powered vehicles. We will start 0, which represents a balanced societal view of both types. After about 30 iterations, we see that the three colors are roughly balanced. And clearly, without external influence, fuel cars and electric cars will fairly divert the market. Next, I will list social bias to strongly favor electric cars. You can see that most agents quickly turn green, and after only a few iterations, the red representing fuel cars almost complete disappears. Finally, we will adjust the social bias to a negative value. And which aligns better with the current reality, where more people still buy fuel cars over electric. This time, we will extend the iteration period to 50 weeks to overall the full decision time for car purchase. After this simulation, the two colors have clear dividing line, showing distinct social structures where customers exhibit confidently due to the surrounding information. So, in reality, support of a fuel car may be even higher than what I have demonstrated, but electric car market hasn't been swapped up and still maintains a growth rate. As mentioned earlier, this is clear diversion by external factors like policy support. And many countries, including Australia, are promoting electric vehicles. This provides consumers with a bias towards electric cars. And also on the flip side, range anxiety corrected negative impressions. We anticipate that with the inclusion of external factor sellers, electric vehicles will continue to occupy a share of the market, even if overall societal attitude isn't favorable towards them.
As Jiang has demonstrated how the model will change based on different initial average purchase intent, I will show how the model will change based on different agents. So if we set agent count at 100 and the stop tick at 52, the number of simulations and agents are small. The model will convert very quickly. So, and if we set the agent count at 2000, the model will not converge. The model will not converge at stop tick at 52. So, but if we set the stop tick big enough, the model will converge. The different convergence speed shows that for a larger sample size, more time is needed for the model to simulate the change in consumers' attitude to the electric vehicle market. This is consistent with the real-world situation that if the electric vehicle wants to occupy larger market share, it needs more time. This model is based on social interactions between consumers, reflects people's attitudes and behaviors toward the electric vehicle market in the real world. When initializing the model, the random initial purchase intention is consistent with the differences between people in the real world. Building social networks simulates the real-world situation where consumers are more likely to influence the people around them by finding the nearest agents to establish connections in the model. Convey purchase intention based on influence and the connection weight can simulate each person's different influence in the real world. Updating color reflects consumers' attitudes toward the electric vehicle market and visualize the model's results in a more intuitive method. So based on our experiment, we found that the initial average intent affects the rate of change of electric vehicles support, and the larger the sample size, the more obvious. That is, when the initial average intent is biased toward 100 or negative 100, the agent in the model will all turn to green or red very fast. It can be seen from the chart that the closer the initial value is to the extreme value, the faster the model converges, which is similar to the situation in the real world, that when the overall society's recognition of electric vehicle is higher, consumers are more likely to buy electric vehicles, and it is the same on the opposite side. Our model has following limitations. The network structure in the model is simplified and only considers the nearest consumers to establish connections. While social network in the real world may be more complex, including long-distance influence and more complex social interactions. The influence and weight in the model are static, which means they do not change throughout the simulation. However, in the real world, an individual's influence may change over time. The model ignores the other factors that may affect purchase intention, such as government support or people's demand for electric vehicles. So to improve the model, first we will attempt to build more complex network. Then we will try to adding weights and influence update and adding external variables to the update rules. Finally, we will try to adding self-correction to the agents, which means an agent may not accept all purchase intention conveyed to it. Thank you for watching. Please be free to ask if you have any questions.